your teachers won't believe that you can solve questions like this. So this is asking you to find the area of a quadrilateral. Now you may know that there's no formula for the area of an irregular quadrilateral like this one. And the only things that you do know are the areas of these two triangles are 1 and 3, and this area of this other quadrilateral is 2. And this shape is a rectangle. So how on earth are you going to relate these areas that you've been given to the area that you asked find? So you could dive in straight away with an algebraic approach here. But let's just take a step back for a moment and have a think, how are we going to relate these things together? So often it's useful to think, well, what if I knew maybe the area of the rectangle? Is there a way that we can get to this area A by subtracting other components of the rectangle? And if you do start thinking along those lines, you might see that inside of the rectangle, there's 4 key triangles, 4 right angle triangles. So we've got this one here, those two, one of the sides is the height of the rectangle, and then we've got 2 triangles where one of the sides is the base of the rectangle. And what you notice is if we subtract away these 4 triangles, we're perfectly left with the area that we're looking for. But that's not enough though, because what we notice is actually we're subtracting some of the areas twice, not just once, because this part with the 3 in, the part with the 2 and the part with the 1 in, they're all parts of 2 different triangles. So we're going to need to somehow account for that. But this is useful because these are the intuitions that are going to help us solve this problem. So for example, if we called the base of the rectangle B, the height of the rectangle H, then we could split up some of these portions so that we can express the area of the rectangle and express the areas of all of the triangles. So we could call this side of the triangle X. So this part would be B minus X. This part we could call Y. So this upper part would be H minus Y. So now we've introduced the algebra to express all of the areas that we need to know. So let's look at these triangles one by one. We can express the areas now in terms of B, H, and X and Y, and just see what happens. So the area of the rectangle is B times H. Now we've called this one triangle 1. Well, this has a base of B minus X and a height of H. We now look at triangle 2. This will be a half times H times X. And now we can look at the 2 triangles that are kind of on their sides. Triangle 3 will be half times Y times B, and triangle 4 will be a half times H minus Y times B. Fantastic. So what we're hoping is going to happen here is that lots of things are going to cancel out nicely. And we know we're looking for is our rectangle minus our 4 triangles, and then adding back on the areas that we took away twice. So the 3, the 2, and the 1. So let's go ahead and do that. So that our area A is going to equal base times the height minus this, minus this, minus this, minus this, add 6. So we've got BH minus a half, and then we've got BH minus XH plus XH, because we factored out the minus a half, remember? And then it's minus a half YB, but we factored out minus a half, so plus YB. And then our last part, we've got, again, factor out the minus a half, B times H minus Y times B. And what you notice here is there's some very nice cancelling that's about to happen. But we don't want to forget that we then have to add on the parts that we subtracted twice, the 1, 2, and 3. So we add on 6 at the end. So what happens here? We've got minus XH plus XH, which cancel. We've got plus YB minus YB, which cancel. And then we've got plus BH. We've got 2 BH here, times a half is just BH. BH minus BH is 0. And we're just left with plus 6. So the area A that we're looking for is just equal to 6. If you like that, let me know in the comments for more content like this.